All right, let's cut right to it. This isn't about hype. This is a technical briefing for developers, pure and simple. In the last few days, both Google and OpenAI dropped their new flagship coding models, basically back to back. So we're going to pop the hood and really dig into what this means for your code, your actual day-to-day workflows, and maybe even your next big project.
Okay, here's the plan. First, we'll look at the new AI arms race that's heating up. Then, we'll dive into the clashing engineering philosophies. This is the really juicy stuff. After that, it's under the hood to look at the API trade-offs you'll actually have to deal with. We'll compare the official benchmarks to what's happening in the real world. And finally, we'll figure out how you choose your next AI co-developer. Let's get into it.
All right, first up, the new AI arms race. And yeah, the timeline here tells you everything you need to know. This isn't just a product cycle. It's a battle for your attention.
So check this out. On November 18th, Google drops Gemini 3 Pro. The very next day, we're talking less than 24 hours later, OpenAI counters with GPT 5.1. You don't need to be a strategist to see what's happening here. This isn't a coincidence. It's a high-stakes chess move, played out in public for all of us to see.
And this quote from Vyom Ramani at digit.in just hits the nail on the head. This really does feel like an open battle for the future of software development. And look, we're not just talking about who writes better getter and setter functions. This is a fight over the fundamental engineering principles that will power the tools we use every single day.
Okay, so what are these clashing philosophies? Because this is where it gets really interesting. We're moving past the feature list and into the core architectural decisions, the why behind the what. This is about two totally different ways to build an AI coding partner.
So it really boils down to two core strategies. You've got OpenAI on one side, focusing on what they call agentic precision. Think of this like a scalpel. It's all about building a super reliable, tool-using agent that you can control with fine-grained precision for really specific, complex coding jobs. Then you've got Google, and they're betting the farm on world-scale context. This is the sledgehammer approach. Just ingest massive, and I mean massive, multimodal data sets and reason over the whole thing in one shot. Let's look at OpenAI's approach first. They've got this thing called adaptive reasoning. The best way to think about it is like a smart turbo boost for the model's brain. If you ask it a simple question, it gives you a quick, cheap answer. But if you're tackling something gnarly, like a big refactor, you can literally turn a dial in the API called reasoning_effort and tell it, hey, spend more time on this, use more compute, and get it right.
And here's their really clever answer to the infinite context problem, compaction. So instead of just crashing and burning when it hits its context limit, the model acts like an operating system. It starts pruning and summarizing the older parts of its history, basically swapping less important memories to disk to free up RAM for what you're asking it to do right now. It's a pretty slick way to keep long-running tasks going.
Now, Google's approach, it's simpler. It's brute force, but kind of beautiful in its own way. Their thinking is, why bother with all that clever memory swapping if you can just give the model a ridiculous 1 million token context window? It's like they decided to solve the problem by just soldering a giant stick of RAM onto the motherboard. You can just dump your entire code base, hours of video, whatever, right into a single prompt.
Okay, so that's the high-level philosophy. Now let's get into the nitty-gritty, the API trade-offs. This is how all that theory actually impacts your code day in and day out.
When it comes to controlling the brain, the defaults tell you everything. With GPT 5.1, the reasoning effort defaults to none. It's built for speed out of the box. You have to opt in to deeper thinking. Gemini 3 is the total opposite. Its thinking level defaults to high, meaning it's designed for deep, complex tasks from the get-go. You have to opt out if you want it to go faster. That's a huge philosophical difference right there.
And this leads us right into a classic computer science trade-off: time versus space. OpenAI's compaction is all about saving space, your context tokens. It's cheaper, but it costs you time and computation to do that summarizing, and you run a tiny risk of information loss. On the other hand, Gemini's 1 million token window is all about saving time. Access is super fast, but you're paying for that space, especially on prompts over 200,000 tokens. It gets pricey.
Okay, let's talk about one of the biggest headaches in building reliable AI agents. You know the problem, right? The API is stateless. Every call is a blank slate, but the task you're trying to accomplish is stateful. So how in the world do you get the model to remember what it was thinking from one API call to the next?
Well, Google has a really interesting solution called thought signatures.
You can think of them like a JWT or a session token, but for the model's brain. So when you ask it to do a multi-step task, it'll call the first tool and hand you back this thought signature. Now it's your job to send that signature back with the tool's result. The model then uses that to pick up where it left off, calls the next tool, and gives you a new signature. The catch? You have to send the entire chain of signatures back every single time to keep its train of thought intact. It's a cool way to fake state over a stateless protocol.
So we've got these two impressive but very different architectures. The big question is, which one's actually better? The benchmarks will tell you one thing, but we all know the real world is a whole different ballgame. Let's look at where the numbers might be a little misleading.
Okay, let's start with the official numbers. This is SWE-Bench, which is a pretty respected benchmark for coding tasks. And look at that. GPT 5.1 at 77.9%, Claude at 77.2%, Gemini at 76.2%. I mean, these scores are so close, they're practically within the margin of error. On paper, this is a dead heat. It's a statistical tie.
But here's the question that actually matters, right? Who cares about benchmarks if the workflow is a pain? Which model actually helps you get your work done faster with less hassle? That's what we really want to know. And for that, we have to look at what developers are saying out in the wild. So in one test, coding a simple app from scratch, Gemini 3 came out on top. The reason was simple. It spat out code that was ready to copy, paste, and run. It just worked right out of the box. No debugging, no fiddling. But then, change the task. For refactoring some really messy legacy code, Claude Sonnet 4.5 was the clear winner. It was way more careful. It actually explained its changes, and critically, it didn't break anything. It acted less like a code generator and more like a cautious senior dev.
And what about the softer skills, like just helping a developer who's feeling stressed out plan their day? Well, for that, the classic ChatGPT 5.1 vibe is still unbeaten. It just feels more like a smart, calm assistant and less like a robot or a strict professor. So, what does this all mean? The big takeaway is pretty clear. There is no single best model. The winner here isn't an AI. It's the developer who knows it's about having the right tool for the right job. So, let's try to build a framework for how to choose. Here's a quick cheat sheet. You should probably lean towards Gemini 3 Pro when your problem is just raw context size. I'm talking combining video, PDFs, and a huge repo all in one go. But you should probably prefer GPT 5.1 when your workflow is all about building complex agents that have to use a bunch of different tools, especially if you're trying to keep costs down on lots of smaller API calls. It's really about choosing between that massive context window and a more precise, tool-heavy approach. And really, that brings us to the most important point of this whole briefing. It's not a monoculture anymore, it's a toolbox. The idea of looking for one single best model to rule them all, that's over. The smartest developers out there are building strategies to use multiple models, routing the right task to the right specialized tool. And that leads us with one last thing to chew on. Is the future really about finding a single best model that does everything? Or is our job as developers changing? Are we becoming less like builders and more like conductors of an orchestra filled with all these specialized AI agents? How we answer that question is probably going to shape what it means to be a software developer for years to come.